Here we have a very interesting problem. I particularly like this problem for reasons that we will see in a short while. Maybe the alert candidate will be able to eventually see the simplicity that lies in the solution of this problem. But let us go through the process, and when we get to that bridge, we will cross it. Before going into the manipulation of the fractions, let us convert the mixed numbers to improper fractions. The first one, as usual, we label the components of the mixed number. The whole number is the component that we label first. Then we have the numerator followed by the denominator. In converting this to an improper fraction, we will first multiply the denominator by the whole number. The result is then added to the numerator. So we have 4 multiplied by 2, and that is equal to 8. 8 plus 1 is equal to 9. Let us see if by the time we get to the next one, we will have anything to write home about. So the 9 will be the numerator of the improper fraction, and the denominator will be the same as before. 1 and 1/8. The same. Multiply the denominator by the whole number, which is the one that we have right here, and to that we will add the numerator. So 8 multiplied by 1 is equal to 8. Then we add 1, and the result is 9. 9. And the denominator is as we had it before. Then we go straight ahead and do the same with 4.5. 4 times 2 is 8, and 8 plus 1 is equal to 9. The 9 that we have calculated is the numerator of the improper fraction, and the denominator will be as it was before, 2. Well, it is quite remarkable that we have 9 over 4, 9 over 8, 9 over 2. But is that the information of greatest significance that we are paying attention to? The original problem, we have it right here, that we may make reference to it if necessary. Rewrite the expression with the improper fractions obtained on the previous slide. So there we have our improper fractions. What have we done? Apart from replacing the large fraction bar with a division sign and enclosing the upper set of fractions in brackets, we will rewrite each fraction with a denominator of 8. And how have we done that? As a matter of fact, we will take a look at this on a later slide. But how do we achieve that? We have 9 over 4. We are making use of the fact that 8 is the lowest common multiple of all the denominators, and we will use 8 as a common denominator. How do we achieve 8 right here? We have 4. To get 8, we will multiply by 2. Cannot just multiply by 2 in the denominator, we will be cheating the problem. Therefore, we multiply the denominator by 2 and the numerator by 2. So we have 4 times 2 is 8. 2 times 9 is 18. As a matter of fact, if we reduce this fraction by a common factor of 2, the result is still 9 over 4. Also, we have 9 over 2 as the lower set of fractions. What do we do? In order to get this to be 8, we are converting to the common denominator of 8. In order to get this to be 8, we multiply 2 by 4. 2 multiplied by 4 is 8. Cannot do that without multiplying the numerator by 4 also. So 4 nines, 36. So we have 36 over 8. By so doing, all the denominators are the same. It is easy to add the fractions right here because they are of the same denominator. Eventually, when we do the reciprocal, the fraction will be easily reduced by a common factor of 8. So 18 plus 9 is 27. 27 over 8, the reciprocal of this is 8 over 36. Immediately we see the 8's cancelling. The expression may be reduced by a common factor of 8, then by a common factor of 9. The answer is 3/4. Common factor of 9 right here. 9 into 27 is 3. 9 into 36 is 4. As mathematicians, we should not be opportunists, but we should not be afraid of making use of opportunities. Seeing that the entire problem may be written with a common factor of 8, not only causes the fractions to be added with great ease, but helps in the process of reducing the fractions in the end, where we have 8 cancelling 8. So by seeing that we have a common factor of 8, or we may write the fractions with a common denominator of 8, we see that in the end reduction is made easier, and also addition of the fractions was made easier. In the end, the process is very nice and spicy. On the next slide, we will take a second look at the process of writing the fractions with the same denominator. Here we have the set of fractions. It should not take much at this level to determine that they may be expressed with a common denominator of 8. We should be able to determine at sight that the LCM is 8. The LCM of all of these denominators is 8, and that will be the common denominator. Conversion to a common denominator of 8 should be a simple process and dependent on the simple principle that multiplying the numerator and denominator of a fraction by the same number does not change its value. Our first fraction is 9 over 4. Write it with a denominator of 8. 4 will be converted to 8 by multiplying by 2. The numerator will also be multiplied by 2. So there we have it, 18 over 4. Note the same with 9 over 2. Write it with a denominator of 8. 2 will be converted to 8 by multiplying by 4. The numerator will also be multiplied by 4. 36 over 8. The processes are simple and may be carried out at sight without any rough work. Be prepared to use these little skills in manipulating fractions. Fractions are not from outer space. They are regular numbers and may be manipulated quite easily if we are ready to expand on the principles that we have learned in primary school. I hope that although we have written this with a denominator of 8, that that does not affect the value of the fraction, because if we reduce this by a common factor of 4, the result will still be 9/2. There we have our arithmetic expression, which we need to express as a single number, or we are required to simplify that expression. What do? Multiplication takes precedence over addition and subtraction. It may also be advantageous to know that squares and square roots are of the same order as multiplication and division. Therefore, we will first multiply 3.96 by 0.25, and we will find the square root of 0.0256. Finish up by carrying out the subtraction process. That's all there is to it. Although square and the square root are on the same level of precedence as multiplication and division, and should be carried out before addition and subtraction, if a sum or difference is under the square root sign, then the square root sign should be treated as a set of brackets that encloses the sum or difference. That sum or difference must therefore be carried out before finding the square root. We do not have the situation that was just described. We do not have it right here. But in the event that we had a sum under the square root sign, before finding the square root, we would have to find the sum, treating the square root sign as a pair of brackets. Find the total cost of the rice by multiplying its unit cost by its mass. Right, so if we need to find the total cost of the rice, which is W, what do we need to do? We need to multiply the quantity by the unit cost, and that will give us the total cost. On the other hand, the total cost is equal to the quantity multiplied by the unit price. If we have the total and we need the unit price, we will have to divide that by the quantity. So here we are finding the value of X. Four multiplied by X, the result is 52.8. Therefore, in order to find X, we need to divide 52.8 by 4, and the result is $13.20. The Y will be analogous to X. This is similar to 2. Find the quantity by dividing the total cost by the unit price. So 14.1 divided by 2.35 is equal to 6, and 6 will actually be the quantity Y, may be the number of quarts of milk. Z is the percentage of the value added tax. We have the subtotal and the monetary value of the value added tax. Write the monetary value as a percentage of the subtotal. So here we have the monetary value of the value added tax, and we have the subtotal. This is added to this, and this is the result. What percentage tax is added to this? So we need to know $9.90 as a percentage of $82.50, and that is 12%. Algebraic fractions. There is no difficulty seeing that the common denominator of the fractions is 12. whenever we have denominators that do not have common factors, we are sure that the common denominator, which is the LCM of them, will be the product of the two of them. 4 times 3 is 12. The common denominator is 12. And what do we do next? 3 into 12 is 4. 4 multiplied by x minus 2. Then 4 into 12 is 3. 3 times all of x plus 1. Expand the brackets. We have 4 times x is 4x. 4 multiplied by negative 2 is negative 8. 3 times x is 3x, and 3 multiplied by 1 is 3. After that, we will put the like terms together. What do we know? 4x plus 3x is 12x, and negative 8 plus 3 is negative 5. 7x minus 5 over 12. Binary operation. And that is our expression of the binary operation. To cause the binary operation to operate on the numbers, just substitute the numbers in the place of the symbols or letters in their respective places. The binary operation is operating on 3 and 4. So 3 plus 4 is equal to 7. We square 7. Then 2 times 3 times 4. So square 7, we get 49. 2 times 3, that will be equal to 6 times 4 is 24. So we will have, in the end, 49 minus 24, and that is equal to 25. Factorization. In the process of factorization, we take the highest common factor of the terms and divide each term by the highest common factor. In this case, we have the highest common factor is xy. So we take xy as the highest common factor, and we will say what? Xy cubed divided by xy. X squared y divided by xy. So we have xy cubed divided by xy, that is y squared, and x squared y divided by xy, that is x. Under examination conditions, it is not necessary to include the intermediate step. I am only here demonstrating the fundamental principles of factorization. Here, the principle is the same, but we will use factorization by grouping, in which we factorize in pairs. Take the common factor of the first pair. So we have 2h is the common factor of the first pair. We divide each term by 2h. Divide the terms by 2h. In the second case, the common factor is negative 3k. So we take negative 3mk and divide by 3k. We are dividing each term by the common factor, as we have that right there. So take the common factor of each term and divide each term by the common factor. I'm sure it is quite visible what we have right here. The terms are returning here, and we are dividing by the common factor. We have the terms returning here and here again, and we are dividing by the common factor. In the end, 2h will cancel, we have m. 2 and h will cancel, we have n. And on the other side, we have something similar. But do not forget that we are dividing by a negative quantity. Negative divided by negative is positive, and positive divided by negative is negative. We will take it a step further by doing the same thing again. Finding the common factor, which is m minus n, as we can see, and we are dividing each term by the common factor. no doubt, m minus n, the common factor, we see that this is divided by m minus n. We divide again this term by m minus n. And quite simple to see what will happen. In the bracket, we will have 2h minus 3k. That is all that will remain when we divide each term by the common factor. So m minus n, 2h minus 3k. This is what we are accustomed to and what is required under examination conditions. In one step, we will write down the common factor, and the result of dividing the terms by the common factor will be placed in brackets, like so. And we imagine that this is a one-step problem, because usually CSEC gives only a single mark for a factorization problem like that. So we are sure we should be able to do it in one step. So take the common factor, and then we say x will cancel x, y into y cubed is y squared. Then down here we say x into x squared is x, and the y's will cancel. And we are expected to do it like this in the examination. What we had on the previous slide was illustrations of the fundamental principles of factorization, in which we are demonstrating that we need to take the common factor and divide each term by the common factor. The simplified version of this problem is also here. In the first step, we will factorize the first two terms by taking a common factor, and we will do the same with the second pair. Common factor we know already to be 2h. 2h will cancel with 2 and h, m. 2h will cancel with 2 and h, n. Then we have negative 3k. Negative into negative is positive. No doubt we have this positive m right here. The 3k, the 3 and the k. Then down here, negative 3 into positive is negative. So we have negative into positive is negative. 3k will cancel with the 3 and the k, and we have n. But we are not done yet. We are expected to see that the common factor is m minus n, and that the other bracket will be comprised of 2h and negative 3k, like so. Do not forget that in the second pair, the common factor is negative, like this. Dividing the second term by it, we'll get 3nk divided by negative 3k. Positive divided by negative is negative. Positive divided by negative results in a negative. When factorizing, we need to be mindful that division should not be without the consideration of signs. If y varies directly as x, then y is equal to the product of x and the constant of proportionality. Y varies directly as x, then y is equal to the product of the constant of proportionality and x. Y is equal to the constant of proportionality multiplied by x. Usually, our first step is to determine the constant of proportionality. This is not very difficult because initial values of the variables x and y are already given to us. First, find the constant of proportionality. That is not difficult because initial values of x and y are already given to us. All we need to do is just substitute those values in this expression. So 12 is equal to k multiplied by 2, and the simple process of dividing by 2 results in k is equal to 6. According to the information in the table, we have the value of x given as 5, and we need to determine the value of y that is given as a. We will make use of the same initial equation as long as we have established our relationship. That is the same relationship that we use on every single occasion. So y is equal to kx. What do? Substitute a for y, 5 for x, and k is equal to 6. A is equal to 6 multiplied by 5, and that is equal to 30. There is no difficulty with that. Finally, the value of y is given to us as 48. B is our value of x, and we already know the constant of proportionality, that it is equal to 6. Use the same relationship, substitute the known values. The only unknown in this particular case will be b. Transpose by dividing by 6, and the answer is b is equal to 8. There's nothing to it. Set theory. Those who study neither art nor music are those that are in the Venn diagram but outside of the sets that represent art and music. And we are trying to be a little bit sophisticated by showing off our knowledge of set theory, that those outside of the set M and the set A are represented by the complement of the union of A and M. So the number of those is 4. We could have just written down 4. In finding the value of x, we need to make use of the fact that the total number of students is 35 and must be equal to the sum of all of the numbers in the different sections of the Venn diagram. Therefore, we have x plus 5 right there. We should have 8, then we have x, then we have 4. We are adding all of the numbers or expressions in the different parts of the Venn diagram. All of those together should be equal to 5 because the number in the universal set is equal to 35. In finding the value of x, we need to make use of the fact that the total number of students is 35 and must be equal to the sum of all of the numbers in the different sections of the Venn diagram. All the x's together, we get 2x. All the numbers on the left hand side, we get 17, and that is equal to 35. By a little transposition, 2x is equal to 35 minus 17, which is equal to 18. Then x is equal to 18 divided by 2, which is equal to 9. So x is equal to 9. Those who study music only are represented by the expression x plus 5, where x is equal to 9. We know that x is equal to 9 already. And those who study music only are those that we have right here. Right. So x plus 5 are those who study music only. They are in the set of those who study music, but not in the set A. X plus 5, where x is equal to 9, so 9 plus 5 is equal to 14 in all. Those who study music only are those that are in the set represented by music, but not in any other set, well, except the universal set, that is. Here we have a lovely construction problem. In ensuring that this construction problem is carried out in a simple process, what we do first is analyze the information that is given to us in order that we can premeditate or predetermine how we will go straight ahead and construct our diagram. Let us take a look at the order in which the information is given and how it will affect how we construct the quadrilateral. First is the line EF followed by the angle EFG. The presence of the points EF in both of them is an indication that one may be drawn exactly after the other. So we have EF, then we have EFG. It means that we may draw the line EF, then construct the angle EFG. EF is present in both of them. We may carry out one followed by the other. What do we notice again? Moving on, we have FG and FG. EFG is followed by FG. Both contain the points F and G. They may therefore be drawn consecutively, one after the other. So we draw EF, then EFG, then FG. That's nice. What do we have here? However, when we get to the angle HEF, we realize that it is not related to the line segment before it, but to the one after it, and also to the first line segment in the list. It is therefore the other angle at the beginning of the first line drawn. Notice what we have: EF, EFG, FG, FG. So we may go in a sequence. When we get here, we realize that EF, notice EF, therefore it is not related to this one, but to the one all the way down here. Therefore we may conclude that the angle HEF is to be drawn at the other end of the initial line. So we will have the angle HEF at the other end of the initial line. Then what? HEF and HE right there. So this one may be drawn immediately after that one. It is not surprising that the angle HEF is related to the line segment that comes exactly after it. In constructing the figure, we may therefore use the information in the same order in which it is given. Draw the line EF first. That is the first thing we do. Then the angle EFG. So draw this line, then draw this angle. Then what do? We draw the line FG. Next, we draw the line FG. And then, although the angle HEF is next, it is to be drawn at the other end of the line segment EF. The segment HE will be next. Complete the diagram by drawing the final line segment. Now that we have an idea what to do, we will go straight ahead and the construction will be a little bit smoother. First, draw the line EF is 8 centimeters. Use your Cambridge ruler and draw the line EF is equal to 8 centimeters. Very nice. Here goes the ruler. What do we do next? Place the center of the protractor at the point that represents the vertex where the angle is located, which is F. The line EF will be the zero line. So EF is the zero line. There we have our protractor. EF is the zero line, and the angle that we are about to construct is the angle EFG. So F is the point that is at the vertex of the angle. So EF is the zero line, and we know the size of that angle. So we will mark the point where 125 degrees will be. or 125 degrees must be taken from 0, 0, 10, 20, 30. Notice that we have this beginning at 180, going down 170. No, cannot be that. The angle must begin at 0 and open all the way around to 125 degrees. Where is 125 degrees? I think we have 120, 125 degrees right here. Lovely. After removing the protractor, use your ruler and the point as a guide to draw FG to be 4 centimeters. FG is 4 centimeters, so let us draw that. 4 centimeters. Lovely. G. What do we do next? We go to the other end of the line and draw the other angle. That's what we discussed. Place the center of the protractor at the other end of the line, which is at E. Again, the line EF will be the 0 line. And what angle are we drawing on this occasion? Mark where the 70 degrees mark is. So locate the 70 degrees mark. Notice that this is the 0 line, so 0 should start here. 10, 20, 30, 40, 50, 60, 70 right there. After removing the protractor, use your ruler and the point as a guide to draw EH is 7 centimeters. Good. The rest of the figure is fixed. All other angles and all other sides are fixed. Therefore, what we imagine that we could do is finish the quadrilateral by drawing the line segment GH that we have done. Measure the distance GH. The distance GH, as we see right there, is about 8.5 centimeters. And that's all there is to it. Now, it is not quite often that we get a construction problem that requires us to use a protractor. But I think that is a very good gesture by the CXC, CSEC examiners. Sometimes the students are just programmed to proceed in a particular fashion by making somewhat of a difference in this problem. Will guarantee that the student who actually gets this one right is one with an open mind. First, we need to solve that inequality. We are required to solve the inequality. Our first step will be to transpose negative 2x to the right hand side and 9 to the left hand side. That we have done. The proposed subject, which is x, is best written as a positive number. Then we divide by 2. Of course, we have 5 minus 9, that is negative 4, that we will divide by 2 in the next step. Dividing the inequality by 2 will eliminate 2 from the right hand side, and on the left hand side we have negative 4 divided by 2 is negative 2. Turn the inequality around. Do not forget that if you are younger than your brother, then your brother is older than you are. Therefore, in changing the inequality around, the inequality sign has to change. So when we are changing this, we need to put the x on the left hand side. But negative 2 is less than x. It means that x must be greater than negative 2. If x is an integer, we need to determine the smallest value that x can take based on the solution of this inequality that we have. X has to be larger than negative 2. The next integer larger than negative 2 is negative 1. Yeah? Is negative 1 larger than negative 2? No, that is what some students will say. 2 is greater than 1, so negative 2 is greater than negative 1. But let's see why this is not so much of a paradox. Integers are numbers, inclusive of positives, negatives, and 0, that are not accompanied by a fractional part. Let us show some integers on the number line. There we have our number line, and we know that numbers increase on our number line from left to right. Therefore, if we start here, then this is larger, this is larger, this is larger. Well, surely when we get onto the positive side, we know that 2 is larger than 1 and 3 is larger than 2. But the sequence is a continuation from the negative side. Therefore, negative 1 is greater than negative 2. On a number line, the numbers are increasing as we go from left to right. Therefore, for 2 consecutive numbers, the larger one is located to the right. This causes the fact that negative 1 is greater than negative 2 not to be the paradox that it first appears to be. It is not quite often that problems that may be done well with illustrative diagrams are solved without them in Richard James Mathematics Resources. However, I think that we will make very good use of our imaginations on this occasion and not use any illustrative diagram. We are given the area of a square, and our duty is to find the length of each side. We will make use of the fact that the area of a square is found by squaring the length of each side. So area is equal to L squared. The area of a square is equal to the square of the length of each side. The square is a rectangle with equal adjacent sides. Therefore, since all sides are equal, the length multiplied by width, the length and the width are equal, we have the area is equal to the square of the length. In this particular case, what do we have? The area is already given to us as 121 centimeters squared, and that is the area of a square, and we need to find the length of each side. And the area of a square is given by L squared. Eliminate the square by finding the square root of the other side. L is equal to the square root of 121, and that is equal to 11. So the length is 11 centimeters. A square has 4 equal sides. Its perimeter is the total of those sides. Its perimeter is therefore equal to 4 times its length. Now that is the way that we will find the perimeter of the square. The perimeter of any shape or figure is the measurement all the way around, which is equal to the total of all of its sides. A square has 4 sides equal in length. Therefore, if the length of one is 11, the perimeter is 4 times 11, and that is equal to 44 centimeters. The length of the wire is the perimeter of the square. It is therefore the circumference of the circle. The square, the wire that is used to form the square, is now used to form a circle. Therefore, the length of the wire will be the circumference of the circle, which is also the perimeter of the square. So the circumference of the circle is 44 centimeters, and that is equal to 2 pi r. 2 multiplied by 22/7 times r. Need to find r And that will be done by transposing the formula, making r the subject. Everything that we have multiplying will be divided on the other side, and everything that we have divided will be multiplied on the other side. So r may be found by transposition. 44 multiplied by 7 over 22 multiplied by 2. See easily that 22 multiplied by 2 is 44. When cancel with this, r is equal to 7 centimeters. Finally, finish up by finding the area of the circle. The area of the circle is given by area is equal to pi r squared. 22 over 7 times the square of the radius. No problem. We have 7 squared right here. Divide this by 7. 1 7 will be left. 7 multiplied by 22 is the same as 14 multiplied by 11, which is 154 centimeters squared. In finding the scale factor of the enlargement, because what we have right here, this triangle and its image after an enlargement, we need first to find the scale factor of the enlargement, and that may be done by take the length of one side of the image and divide it by the length of one side of the original. One is given right here. So m prime n prime divided by mn, that is 16 divided by 8, and the scale factor is equal to 2. Although we already know that OM is equal to 10 centimeters, OMN is a right angle triangle in which the longest side is missing, which is of course OM. Pythagoras theorem may be used to find OM. OM is the hypotenuse. We have two short sides. Use Pythagoras. 6 squared plus 8 squared. The square root of all of that. When we square 6, we get 36. When we square 8, we get 64. Add those, we get 100. The square root of 100 is positive or negative 10, but we are talking about the side of a triangle cannot have a negative value, so OM is 10 centimeters. The relationship between an object and its image in an enlargement is such that the length of any side of the image is equal to the length of the corresponding side of the object multiplied by the scale factor. We need to find OM prime. In order to find OM prime, we take the length of the side of the triangle, the original, and multiply that by the scale factor, and we will have the length of OM prime. So OM prime is equal to the length of the original corresponding side multiplied by the scale factor. The scale factor is 2 and OM is 10. OM prime is therefore equal to 2 times 10, 20 centimeters. Multiple choice solutions contain extensive explanation on right-angled triangles that may be consulted in order that we might understand how it is possible to look at the problem and know that OM is 10 centimeters. QS is opposite to 15 degrees. And of course, the triangle PQS is right angled. So QS in this right angled triangle is opposite to the angle that is 15 degrees. That is PQS. QS is opposite to the 15 degrees angle in the triangle PQS. So this is QS and it is opposite to the 15 degrees angle. The other side, 12.6 meters, is the known side, and that side is the hypotenuse. So QS is the opposite. We have the hypotenuse. The trig ratio that pertains to opposite and hypotenuse is the sine trig ratio. So opposite over hypotenuse is equal to sine of 15. So QS over 12 is equal to sine 15. And there we have the opposite to this angle is QS. As we can see, opposite on the other side of facing QS, 15 degrees opposite to the side QS, or we may say QS is opposite to the 15 degrees angle. The adjacent side we have right here, and the hypotenuse is the longest side. So we are working in order to find QS, which is the opposite, and the hypotenuse is 12.6. The sine trig ratio is applicable. Substitute, we have QS over 12.6 is equal to sine 15 by transposing QS is equal to 12.6 sine 15, and that in one shot is 3.26 meters. Next, we will find this angle Q right here, that is described to be what? RQS. RQS is in the other right angled triangle, which is this one that we have right over here. So RQS is in the other right angled triangle. Adjacent to that angle, which is RQS, we have 3.26 meters. So if we are talking about the angle at Q, which is the angle RQS, adjacent to that angle we have 3.26 meters. The hypotenuse is the longest side, and opposite to it we have SR. Therefore, what we need to find is RQS. This side is adjacent, that we know, and we also know the hypotenuse. The trig ratio that makes use of adjacent and hypotenuse is cosine, and cosine is equal to adjacent over hypotenuse. 3.26 over 8.4 simplifies to give 0.388. So cos of RQS is 0.388. In order to find RQS, we need to take the inverse of the cosine, which is the cos inverse of 0.388. So RQS is equal to cos inverse of 0.388, and what do we have that to be? RQS is 67.2 degrees. Kind of place it right here in a crowd, but in a few seconds we will have it quite clearly shown. So RQS is 67.2 degrees. There we have it. We need to find the area of the triangle PQR, this large triangle. That may be done as long as we have two of its sides and the angle that they form. We have PQ is equal to 12.6. Here, two sides. We have PQ is 12.6, and we have QR is 8.4. So we have two sides of that triangle. We need to have also the angle that the two sides form. But only a part of the angle that they form is known, which is this part, 67.2. We need to know this one. It can be determined quite easily nonetheless. So there we have the two sides. What do we know? In this right angle triangle, we have the 90 degrees angle, no doubt, and 15 degrees. So the other angle is 90 minus 15, which is 75 degrees. So the entire big angle right there, which is PQR, PQR, this angle, is the sum of 75 and 62.7, and that gives us 142.2 degrees. The area of any triangle may be found by taking half of the product of any two sides and multiplying by sine of the angle that the two sides form, like this formula, half AB sine C, where A and B are two sides of a triangle and C is the angle that the two sides form. The two sides that form the angle are 12.6 meters and 8.4 meters, and the angle that those two sides form is the sum of these two angles, which turned out to be 142.2 degrees. So half 12.6, 8.4 sine of the angle that those two sides form turns out to be 32.4 meters squared. Some candidates may fall into the trap of attempting to use half base times height in calculating the area. This is especially that QS is perpendicular to PR and we have its length already. So this, we have QS is perpendicular to PR, so we can use base and the height, and this, the height, is known already, so the students may fall in a trap. In finding PR, we need the lengths PS and SR, both of which are presently unknown. Being mindful of the formula that we used and not afraid to use it have proven to be a savior of time and energy. So if we were about to use half base times height, we would have to find the length of this one and the length of this one, put both of them together, and that will give us the base. But of course we will have to apply trigonometry to both of those, which will be very time consuming, at least a lot more time consuming than realizing that this is 15, this is 90, this has to be 75, and this entire angle is 142.2 degrees. Use the two sides that form an angle and the angle that the two sides form in order to determine the area of any triangle. Functions. G of x is x minus 2 over 3 and f of x is 6x plus 8. There we have g of x. I imagine that we're going to use it first. To find g of a half, substitute a half in the place of x in the function g. So x is a half, so a half minus 2 over 3. It is not difficult to see that a half minus 2 is equal to negative 3 over 2, but we will look at that on a subsequent slide. So we have a half minus 2 to be subtracted from a half, and that is negative 3 over 2. The fraction may be reduced by a common factor of 3. This might be too big of a slice to swallow, but we will continue and demonstrate how simple this is on a subsequent slide. G of x is equal to x minus 2 over 3. In finding the composite function g of f of x, substitute f in the place of x in the function g. We are finding g of f of x. So g is operating on f. So g of x is x minus 2 over 3. G of f is f minus 2 over 3. That is always a good initial step to take in composing functions, because the common mistake that students make is that when composing functions they substitute the wrong function into the other. but by saying g of x is x minus 2 over 3 and g of f is f minus 2 over 3, then we have guarded against such a mistake, and we have an initial step that demonstrates that we know exactly what we are doing. Next, replace the occurrence of f with its algebraic representation. So where we see f, we put the algebraic representation of f. What is f? 6x plus 8. Put that in there. 6x plus 8 minus 2 all over 3. 6x plus 8 minus 2 over 3. Positive 8 minus 2 is positive 6. So we have 6x plus 6 divided by 3. And we may simplify that by taking a common factor of 3 in the numerator. Taking a common factor of 3, what do we have? 3 open bracket 2x plus 2. 3 open bracket 2x plus 2. And that we will divide by 3. When we do that, what do we know? 3 cancels 3 and we have 2x plus 2. The fraction may consequently be reduced by a common factor of 3. The 3's are gone. G of f is 2x plus 2. Now we will take a look at the manipulation of the fractions. A half minus 2. In simplifying that arithmetic expression, let us consider that 2 may also be written as a fraction as 2 over 1. So replace 2 with 2 over 1. What do we do next? The common denominator is 2. Remember that multiplying the numerator and denominator of a fraction by the same number does not change its value. So multiply both numerator and denominator by 2 in order that the denominator can be 2. But what will happen? The numerator will be 4. So we have 1 over 2 minus 4 over 2. The denominators are the same. We will just simplify by manipulating the numerators. 1 minus 4 is negative 3. So negative 3 over 2, and we have simplified that. Now we will divide negative 3 over 2 by 3 and see what happens. Let us see how the expression may be reduced. We know that a fraction bar means division. Let us replace the fraction bar with a division sign. So 3 over 2 divide by 3. Negative 3 over 2 divide by 3. That's nice. Then what do we do? Go ahead again and say that dividing by a number is the same as multiplying by its reciprocal. And the reciprocal of 3 is 1 over 3. So we have negative 3 over 2 multiplied by 1 over 3. Then the fractions may be reduced by a common factor of 3, as we can see. And the answer is a negative a half. Right. So we have negative a half right there. Is the result? There's no difficulty seeing how we arrived at it. G of f is equal to 6x plus 6 divided by 3. We reduce the fraction by a common factor of 3. For our basic fractions, we cannot reduce them unless we have a common factor. We choose to factorize the numerator. That was not a necessity, as long as the step implies that we are making use of a common factor in the numerator. So from our basic fractions, we cannot reduce them unless we have a factor that is common to both numerator and denominator. And the same thing applies to this algebraic fraction. Cannot reduce unless we have a common factor in the numerator and denominator. In this particular case, the common factor is 3. Now, we did not need to factorize. as long as the step that we are taking is suggesting that we are making use of a common factor that exists in both numerator and denominator. F of x is 6x plus 8. One method of finding the inverse of a function is to take the function, say f, substitute x for f of x and f of x for x. That we will do 100 times. Also, since in the end the expression that we will find is actually the inverse of the function f, it is more appropriate to have f inverse rather than f in the expression. So we have x is equal to 6f of x plus 8. But when we transpose this, making the subject of the formula, the expression that we would have found is the inverse of the function. So it is more appropriate to write f inverse right there rather than f of x. We may now transpose the formula, making f inverse of x the subject, the first step of which is eliminating the positive 8 from the right hand side. So x minus 8 is equal to 6f inverse of x. Then we need to finish up by eliminating the 6, dividing by 6 on the left hand side. It is more appropriate to write the inverse of the function on the left hand side, so let us turn this around. And that is our answer. I love this problem because life can be made easy if we use the grid judiciously. Write the coordinates of A and B. That's not difficult. For A, what do we have? For A, move 2 units in the negative x direction, and then we will move 3 units in the positive y direction. Negative 2, 3. For B, we will move 4 units in the positive x direction, followed by 6 units in the positive y direction. 4, 6. The presence of the points and the line segment on the grid simplifies the calculation of the parameters that pertain to the line. The presence of the points and the line segment on the grid simplifies the calculation of the parameters that pertain to the line. The gradient of a line tells us how steep it is. That is, how much it goes up as it goes across. This may be simplified to say y difference over x difference, change in y over change in x, or rise over run. Instead of using our usual formula, which is the gradient is y2 minus y1 over x2 minus x1, we may choose any 2 points on the line and see how much we go across as we go up. So instead of taking the 2 points that we have here and finding the gradient by saying 6 minus 3 over 4 minus negative 2, then we have another approach that we may take by using the appearance of the line segment on the grid. We may choose the horizontal movement to be 1. If we choose the horizontal movement to be 1, this will simplify our calculation because we will be dividing by 1. Do not forget that is what? Vertical difference over horizontal difference. So if we divide by the horizontal difference of 1, then we know that whatever we have for the vertical movement, that will be the answer, because anything divided by 1 is equal to that same thing. So we use 1. So we start here, we go across 1 unit. So 1 goes there. Then we go up. Notice that by the time we are going up, that's just half of a unit from 4 to 5. That's halfway up. So that is half of a unit. So we go up by half of a unit, like so. M is a half over 1. Anything divided by 1 is that same thing. Therefore, the gradient is equal to a half. As stated before, the presence of the points and the line segment on the grid simplifies the calculation of the parameters that pertain to the line. This fact may be extended to determining the equation of the line. The general form of the equation of a straight line is y is equal to mx plus c. M is the gradient that we have calculated on the previous slide, and c is the y-intercept, where the line crosses the y-axis, which is at 4. Let us write the equation of the line, substituting the value of m is equal to a half as we have calculated, and the value of c is equal to 4 as we see on the grid in their respective places. Y equal mx plus c. M is the gradient that we have found to be a half, and c is the y-intercept that is equal to 4. So y is equal to a half of x plus 4, and that's all there is to it. The examiners are expecting the alert candidate to see the simplicity in the problem that is afforded by the presence of the grid. Nevertheless, they will not be alarmed by those who choose to use the formula in making their calculations. The former is not a shortcut, but making use of a glorious opportunity. So we are making use of a glorious opportunity, that one that is afforded to us by the presence of the line on the grid, by which we can just use a little segment of it in order to determine the gradient, and also make use of the fact that this is the y-intercept. Statistic, cumulative frequency. Let us complete the cumulative frequency column. Completing the cumulative frequency column is a matter of accumulating the frequencies as we traverse the frequency column downwards. Therefore, to the present value of the cumulative frequency, we will add the next value in the frequency column as shown. 40 plus 30 is equal to 70. 70 plus 22 is equal to 92. 92 plus 8 is equal to 100. We have completed the cumulative frequency column. The cumulative frequency curve is drawn by plotting the cumulative frequency against the upper boundaries of the class intervals. Recall and make use of the fact that the upper boundaries of the class interval are always a half of a unit greater than their not respective but associated upper class limits. The boundaries will be a half a unit greater than those. Go to the next slide and do likewise. 10.5 is the upper class boundary and the cumulative frequency is 12. So the time is where we have the upper class boundaries. So 10.5 and we go up to 12. Then we have what? 20.5 and we go up to 40. 30.5 and we go up to 70. 40.5 and we go up to 92. 50.5 and we go up to 100. The curve cannot be left hanging. It has to touch the axis where the upper class boundary of the class that is previous to the first would have been. The upper class boundary that is previous to the first would have been. Look at the sequence going down. So we have 30.5, 20.5, 10.5. We are going down by 10 each time. So if we subtract 10 from 10.5, we will get 0.5. The next number in the sequence going down is 0.5. That is where the curve will touch the axis. And we have our smooth curve that passes through all of the points. Lovely. That's very nice. The median. The median is the middle score and is associated with a half of the total cumulative frequency. A half of 100 is 50. The median is associated with a cumulative frequency of 50. Draw a horizontal line from 50 on the cumulative frequency axis to meet the curve. So 50 on the cumulative frequency curve meets, on the cumulative frequency axis, meets the curve right there. Then what do? Where the line meets the curve, draw a vertical line to meet the horizontal axis. That's where it meets the horizontal axis. Where the vertical line meets the mass axis, we find the value of the median. So the median is 24 kilograms. Find the probability that a package will have a mass less than 35 kilograms by first finding the number of packages that have a mass that is less than 35 kilograms. Draw a vertical line where mass is equal to 35 to meet the curve. Draw a horizontal line to meet the cumulative frequency axis. That will be the cumulative frequency of interest right there, 80. We are talking about a mass that is less than 35 kilograms. The region of interest will be from 0 to 80. The probability is equal to the number divided by the total cumulative frequency. So 80 over 100, and that is our probability.